Advanced Math Lesson 28, Factorial Notation, and Abstract Rate Problems. Factorial Notation is actually a lot of fun and really easy. I'll just go into writing it. So we should remember from our lesson that when we write a factorial, like 6 exclamation point, and yes, that's it, just exclamation point, that means factorial. All that means is 6 times 5 times 4 times 3 times 2 times 1. That's it. That's all factorial means. You take the number, you multiply it by each number until you get all the way down to 1. Now, let's say they want us to evaluate 6 factorial. Well, all we have to do is multiply. So, to evaluate 6 factorial, we just take 6 times 5, which is 30. 30 times 4, which is 120. 120 times 3, which is 360. 360 times 2, which is 720. And 720 times 1, which is 720. So that's factorial notation. That's how you evaluate factorial notation. But it's never that easy. Now, the problems you're going to get are like this. They want you to evaluate 9 factorial divided by 3 factorial and 5 factorial, but you cannot use a calculator. This is not impossible. All we have to do is rewrite these. So we'll rewrite this and we'll put 9 times 8 times 6 times 5 times 4 times 3 times whoops times 2 times 1 times whoops. Okay, and then the bottom 3 factorial, which is 3 times 2 times 1. And 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now, the cool thing that you see here is that 5 factorial, this matches all of these. So I can cross these out right away, because 5 divided by 5, 4 divided by 4, 4 divided by 4, 3 divided by 3, 2 divided by 2, 1 divided by 1. That's a really cool trick. Now, the rest of these, I can do some other cool things here too. Like I can take 3 and 6, I can divide those. That goes in 1, that goes in 2, and then 2 and 2 cancel. So then all I'm left with is 9 times 8. What's 9 times 8? 72. So the answer is 72. Too easy. Oh, no, it's not too easy because Mr. Claiborne doesn't know how to count. Hold on, I'm missing a 7 in here. 9 times 7, 9 times 8 times 7 times 6. I was like, wait, I just glanced over to check the answer. I was like, wait, how am I so far off? I didn't miss anything. I forgot to have the count. So it's actually 9 times 8, which is 72, and then times 7, which 72 times 7, let's see here, 14, 49, 50, 504. That is your real final answer. All right, so assuming that you can count to 9, which I can't, these should be really easy for you. Now, let's see here. Yep, that's as complex as those problems get. So let's go on to something even better. Abstract rate problems. Abstract meaning that we're not going to get to deal in whole numbers. Some of our numbers are going to be unknown variables. Now, before we start working on abstract rate problems, there's one equation you need to remember. That is distance equals rate times time. We're going to use this equation a lot, and we're going to use it in a lot of different ways. So, let's start here. Example 28.5. The train traveled m miles at p miles per hour and still arrived 1 hour late. They want to know how fast the train should have traveled to have arrived on time. Okay, so let's go ahead and write this out. Distance equals m, rate is p, and the time it's not given to us, but it's late. So we'll go ahead and fill this in. Our distance m equals p times time. Now, how fast should the train have traveled to arrive on time? So, what we need to do is we need to solve for time here, since we don't know what time is. And we can express time in terms of m and p. So if we want to solve for time, just divide each side by p. So voila, time equals m over p. And we can say distance equals m, and rate equals p. So what we need to do is find a new rate. Now, how are we going to figure this out? Well, let's just start another distance, rate, time equation. The distance is going to remain the same, which is m. All right, so distance is going to equal rate times time. Our new time has to be 1 hour shorter, right? Because it was an hour late. So we'll take our current time and we'll subtract 1. So if we have m over p minus 1, that would get us on time. All right, and then we just need to solve for what our rate is going to be. Well, this is just like our abstract equations that we've already been solving. We'll take the rate, we'll distribute it, and we get Rm over P minus R. All that's going to equal M. From here, I need to multiply R over 1 by P over P. So that way I get Rm minus Rp all over P. That's going to equal M. From here, I can multiply each side by P. That will cancel out. So now my new equation is Pm equals Rm minus Rp. From here, our unknown, which is R, can be factored out. We'll rewrite that as R times M minus P. And if you're really good at these abstract equations, you already know where we're going with this. We're going to take R, we're going to divide it by M minus P. That cancels. And our new rate is going to be P times M over M minus P. Problem solved. All right, that might have been a little too fast for some of you, so we'll go ahead and do another example. And this example is a little bit different, but again, the key to most of these problems is figuring out how to express your unknowns. So we'll start with the boat problem. All right, so the boat traveled K miles in T hours and was 40 miles short of the goal when the gun went off. If the skipper tried again, how long would it take to reach the goal if she increased the rate of travel by 10 miles per hour? Wow, female boat captain, very progressive here. I like it. All right. Somebody in this class is going to comment about how I'm a misogynist. All right, go ahead and leave your patriarchal, bashing comments below. Don't do that. Actually, I'm probably going to have to disable comments for this video and the rest of them. Should I restart it? Nope, not restarting this video. Okay, this example. The boat traveled K miles in T hours and was 40 miles short of the goal when the gun went off. If the skipper tried again, how long would it take to reach the goal if she increased the rate of travel by 10 miles per hour? All right, again, we have to express our distance, rate, time equation in terms of K and T, and then, what the actual distance was. So the actual distance for our first equation, I'll go ahead and put this up top, distance equals rate times time. Our actual distance was K. And our time was T hours, okay? And our rate is unknown. So in this case, we'll solve for our rate. We'll divide each side by T. And bam, our rate is K divided by T. So in our little key here, I'm going to put distance equals K, time equals T, and rate equals K over T. That's the key to these problems, really, is once you set up your first equation to express distance, rate, and time in terms of the letters that you have. So once I've got this, I can go ahead and start working to fix the problem. So the problem is that they were 40 miles short of the goal when the gun went off. Now they want to try again, and they want to find out how long it's going to take to reach the goal if the speed increases by 10 miles an hour. So we're going to take our rate, and we're going to add 10. So our new distance, well, our distance is the same. It's still going to be K. Our new rate is K over T plus 10. And our new time, which is unknown, they want to find out how long it's going to take to reach the goal. Well, I'll just go ahead and I'm going to represent this with X, because if I put T back in there, it's going to get a little confusing. So I'm going to put X there. And then I'm going to go ahead and solve this really similar to the last one. I'll go ahead and distribute X. I get Kx over T equals, plus equals Kx over T plus 10 times X equals K. From here I'm going to add my fractions, but before I can add my fractions, I have common denominator. So then what I get is Kx plus 10xt all over t. That's going to equal k. From here I multiply, oh, I'm off the paper. There we go. From there I'm going to multiply each side by t. That cancels. So then I get kt, because I like things in alphabetical order, equals kx. Just as soon as I said it, I see that I have x in front of t. So I mostly like things in alphabetical order. All right, and then from here, I see my unknown, which is x. I can factor it out. It's going to be x times parentheses k plus 10t. That's going to equal kt. From here, I'll divide by k plus 10t. That will cancel. X equals this, and that is my answer. So now we know how to solve abstract distance rate time problems. All right. Yep, that's all there is. If you have any questions, go ahead and message me on Moodle, and I'll see you guys next class.